Dividing polynomials, remainder and factor theorems. So remember, math is building, so we have to do a little review over long division before we do some dividing of polynomials. Okay, so we're going to do a little review. So we got 26 is dividing into 3,983. So remember, when you first look at it, you got to divide and see how many times will 26 divide into 39. 26 goes into 39 one time. 1 times 26, 26. Then you subtract and you bring down. Then you start over again and you divide. 138 divided by 26. You got 5. You multiply 5 times 26. 130. You subtract. You bring down. Right? And then you have to divide again. The 3 goes in there. 3 times 26. 78. You subtract. You have nothing to bring down. So that means that 5 is your remainder. And your final answer would be 153 would be your quotient. 5 would be your remainder over 26. So if you had to write it as a fraction, that would be your answer. But keep in mind, your steps are divide, multiply, subtract, bring down. And we keep dividing, multiplying, subtracting, bringing down until you have no more numbers to bring down. Right? And if this was written out as a fraction, it would have been 3983 divided by 26. So sometimes as polynomials, we're going to see it as a fraction, and we got to know how to write it as a division problem. Okay, so dividing or long division polynomials. It says arrange the items or arrange the terms of both the dividend and the divisor in descending powers. So they want you to put the terms in order from the greatest exponent to the smallest. Biggest to smallest. That's what descending means. And then it says divide the first term in the dividend by the first term in the divisor. And then it says multiply every term in the divisor. Then it says subtract. And remember, subtracting with polynomials means your signs are going to change. Change signs. And then it says bring down. And it says use this new expression as the dividend and repeat this process until the remainder can no longer be divided, or until you have no other things to bring down. Okay, so when it says subtract the product from the dividend, you got to remember, let's say a long time ago, or in a couple of sections back, we had something similar to this. And so we had to subtract these two things. But when we subtracted, the signs in this polynomial changed. So the 5x plus 3 stayed. And then this became a minus 2x. And this became a plus 3. Because my signs changed. When you're subtracting, you got to change your signs. I changed both my signs. So we got to keep that in mind when we're doing long division. So, see, can we do a couple? Don't know if I'm going to have enough room, but we're surely going to try. It says divide. So I have x cubed minus 3x squared plus 7x minus 5 divided by x minus 1. And then they showed me how they wanted me to put my answer. Okay, so when I divide, there it goes. Well, I don't know. I think I need to have more room. Maybe I start at the very top. Okay, I'm going to start at the very top. So I'm going to have x minus 1. And that's going to go divide into x3 minus 3x2 plus 7x minus 5. So remember, our steps was divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay, so when I divide, it says the first term, so I'm dividing my first term, my x, into x cubed. So either you're dividing by saying x cubed divided by x. Either you're dividing or you gotta see, what can I multiply times x to get x cubed? X times what gives me x cubed? That would be x squared. Or if you divided x cubed divided by x, you'd get x squared. So notice it's 1 power less than what I started off with. And so when I write my answer, I'm starting my answer over the x squared section, or the x squared term, right? Okay, so I divided, now I gotta multiply. When I multiply, I gotta multiply my x squared times my x, and my x squared times my minus 1. X squared times x, x cubed, x squared minus 1 times minus 1 is a minus x squared. Okay, my next step is to subtract. Subtract means I'm going to change my signs, which means this is going to go from a regular x cubed to a minus x cubed, and this is going to go from a minus x squared to a plus x squared. Subtract means my signs are changing. So my x cubes, they cancel out, and negative 3x squared plus 1x squared gives me a negative 2x squared. Then I got to bring down that 7x. Okay, so now I got to divide again. I got to divide my negative 2x squared by x. My first term by my first term. I'm dividing. So either you can divide it, or you can say to yourself, x times what? 1x times what will give me a negative 2x squared. And either way you look at it, it'll give you negative 2x. Alright? So if I divided this, I got a negative 2. And when I subtract my exponents, I would have just had 1x left. Alright? Either way you go, you can divide it, or you can think of it as x times what gives me this, whichever way makes you feel better. Okay, so we divide it, then you multiply. 2x times x, negative 2x squared, 2x times 1, negative times negative, make that a positive 2x. Now I got to subtract, which means change my signs, which makes this a plus and this a negative. 7 take away 2 gives me 5x. Then I got to start all over again. I just brought down my 5. Now I got to start with divide again. So I'm doing 5x divided by x, which gives me 5. Divide. Then I multiply 5 times x. 5x. 5 times 1. Minus 5. Then I change both my signs. And I get a remainder of 0. So if I had to write my answer in this form, out in front would be the x squared minus 2x plus 5. And then for my fraction, since my remainder was 0, I'd put my 0 on top over x minus 1. Now usually, if we have a 0 remainder, this part is not necessary. But if they say, hey, put it in this form, then we're just trying to check to make sure you know that the remainder goes on top. Okay? Alright, so that's long division. And there should be like a mini review. That's long division. Today, we're going to go over another way to divide polynomials called synthetic division. It's not as many steps, but for some reason, sometimes people don't understand and they make little oopsies. So you got to pay attention to your signs with this one. So that's dividing, long division. This is going to be synthetic division. And we're going to do synthetic division using the same problem. Okay, so first let me show you what they did with their synthetic division. Let's zoom in a smidget. So it says synthetic division to divide. So they had x minus c, or x minus 3 as the divisor, as the thing on the outside. So this is the long division part. They showed the long division, the divide, multiply, subtract, bring down. Alright, but they had the x minus 3. So when they did synthetic division, oh, I gotta move it up, you can't see. When they did synthetic division, they brought the 3 and put it in a little box. This is a new way to do it, synthetic division. And then they looked to see what were my terms, what are my coefficients on each term. So I had 1, so they wrote a 1, 4, negative 5, 5. So they wrote down the number for each one of my terms. 1, 4, negative 5, 5. 1, 4, negative 5, 5. Okay, and then they did synthetic division. Synthetic division, they brought down their 1, and then they did 1 times 3. 1 times 3 gave them 3. They did 4 plus 3, 7. And then they did it again, 7 times 3. 7 times 3 gave them 21. Negative 5 plus 21 is 16. 16 times 3, 48. 5 plus 48, 53. So look, their answer they got was 1, 7, 16, 53. So when they wrote their answers, they started off with an x cubed. So it'll be 1x squared, because it started off with an x cubed. So you got to be, power has to be 1 less than whatever you start off with. So it'll be 1x squared plus 7x plus 16, and then my remainder is 53. If I want to put that as a fraction, I'm going to go 53 over x minus 3. Okay, so what we're going to do is we're going to do synthetic division on the problem we just did above. I'm going to do synthetic division on this problem here. So with synthetic division, this should be my answer at the end, because this is what I got for long division when I did long division. To do synthetic division, first I got x minus 1. So that means the answer number that goes in my little box is a positive 1. Then I write down all the numbers that's in front of my terms. I got a 1, a negative 3, a positive 7, a negative 5. Okay, so I bring down my 1. 1 times 1 is 1. Then I go negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. 7 minus 2 is 5. 5 times 1 is 5, and my remainder is 0. So look, 1x squared minus 2x plus 5, remainder 0. So this thing here, that's your remainder. So the way this worked out, since this is our remainder, that means this would have been a factor for this problem, which means if I multiply x squared minus 2x plus 5 times x minus 1, if I multiply those two things back by each other, I should get this. We should. Okay. Alright. We got another one. It says divide by using synthetic division. So, when I'm looking at it, it has x plus 3. So in my little box, I put the opposite. My 0 would have been a negative 3, and my box goes a negative 3. Just pretend like you solved this and put x plus 3 equals 0. your solution, your zero, your x-intercept, whatever way you want to look at it. But the opposite of whatever you're dividing by, that's what goes here. Negative 3. And then I have 5, 7, negative 21. So, bring down my 5. 5 times negative 3, negative 15. Then I have a negative 8. Negative 8 times negative 3, 24. Then I got a positive 3. So, those are my numbers. The key is to remember, hey, how do I write my answer? So, my original problem was 5x squared. When I write my answer, I have to start off with 1 power less. So, 1 less than 2 means I just have 5x minus 8. My remainder is 3, which means it'll be 3 over x plus 3. Okay. Then we got one more synthetic division. Dividing using synthetic division. Then we're going to use the synthetic division to find something else. Dun dun dun. Alright, so notice with this one, I have them in descending order. 5, 3, and then nothing. But I don't have all my powers are not represented. Because I have x to the 5th. I don't have anything with x to the 4th on it. I have an x to the 3rd, but I don't have an x to the squared or x on it. So when you have problems like this, when you're doing synthetic division, you have to make sure you put a 0 to represent that spot or that number or that term. Okay, so outside the box is a positive 1 because I got a negative 1, so my box will be a positive 1. Now I have to start. My numerical coefficient on x to the 5th is 1. X to the 4th, I don't have an x to the 4th, so I have 0 x to the 4th, so I put a 0. I have an 8 for my x cubed. I have 0 x squared, 0 x's, and then I have a negative 9. So you got to be careful. Make sure you don't put too many zeros. So I have a 0 here for 0 x to the 4th. And then I have 2 zeros over here. A 0 for 0 x squared. And a 0 for 0 x's. Okay, so then I bring down my 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 8 plus 1 is 9. 9 times 1 is 9. 9 times 1 is 9. 9 times 1 is 9, and my remainder is 0. Nice. So now when I write my answer, because my first term, the power of this whole polynomial was 5, x to the 5th, I have to start off with 1 less. So when I start writing 1 less, instead of having x to the 5th, I can start off with x to the 4th. So I got 1 x to the 4th, then that's a positive 1 x cubed. So positive 9x squared, positive 9x plus 9, and then my remainder is 0, which would be 0 over x minus 1. Oops, and you couldn't see all of it. Ta-da! Okay, so that is dividing using synthetic division. In synthetic division, a little bit easier than long division, yes, but they still wanted to make sure you understood long division. Okay, you wouldn't appreciate synthetic division as much if they wouldn't have started off with long division. Now you can appreciate it. Alright, so now we have a factor theorem. It says let f of x be a polynomial. I'm trying to zoom out so you can see all of it. There it goes. Let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c equals 0. So that's saying if I plug in whatever the number is and I get 0, then x minus whatever that number is, that is a factor. It means a factor of it. So like on this one, it says solve the equation of this given that negative 1 is a 0. They're already telling me one of my x-intercepts, one of my solutions, one of my zeros is -1. So that's telling me one of my factors is automatically x plus 1. That's what this is for. Okay, that's what this rule is saying. Okay, and it says if x plus 1 is a factor, then f of x, then fc equals 0, which means when I plug -1 back into my function, I should get 0. So if I go -1 cubed minus 5 times -1 squared plus 2 times -1 plus 8, I should get 0. So you can check that and see. Okay, so it says solve the equation given that -1 is a 0, and they want me to find the solution set. Okay, so if this is indeed a 0, that means it is a factor, which means when I do synthetic division, my remainder should be 0. So let's see. And if when I do it, my remainder is 0, whatever I have left is the other factor of this polynomial or this equation. So let's do synthetic division. So for my synthetic division, I got -1. If I would have started off with x plus 1, then I would have changed my sign. Since they gave me, hey, my 0 is -1, I just put -1. And then my numerical coefficient is 1, -5, 2, and 8. So again, since -1 is a 0, that means that my remainder here should be 0. Let's check it and make sure. So I bring down my 1. 1 times -1, -1. So then I get -6. -6 times -1, 6. 6 plus 2 is 8. 8 times -1, -8. Look at that. Remainder 0. So with my remainder 0, then that means this is a factor. When I multiply this times x plus 1, I should get my original equation back. So my answer is x squared minus 6x plus 8. Okay. Okay. And I'm saying okay because I'm looking at it and trying to see, can I factor this? I think I can factor that. Okay, so if I'm solving the equation, that means I'm trying to find all the x's that'll make this equal 0, right? They gave me one of my zeros, so I got to find my other two. If this is x cubed, that means I could possibly have 3 real zeros, 3 places where it could cross the x-axis. So they gave me one of them. I got to find my other one, and looking at this one, I can factor it. So what can I multiply to get 8 and add to get -6? That'll be a -2 and a -4. Then I said x minus 2 equal to 0, x minus 4 equal to 0, x equals 2, x equals 4. So my solutions, if I had to write down all my solutions, I got -1, 2, and 4. Yay, us. So those are all 3 of my solutions. Okay. Okay. So let's look at this one up down here. It says use synthetic division in the Riemann theorem to indicate or to find the indicated function value. Okay, so we know from experience that this means I should plug a 3 in wherever there's an x. 3 to the 4th plus 3 times 3 to the 3rd plus 9 times 3 squared minus 6 times 3 minus 5. We know that's what that means. Right. Okay, so it says use synthetic division. So another way, so notice up here with synthetic division. So notice up here, we said, hey, this is supposed to equal 0. And so that's how I knew my remainder is supposed to be 0. And it was 0. It's supposed to equal. When I plug in my numbers, it's supposed to equal 0. Okay, so with this one, in order to see what this is going to equal, I could do synthetic division. So let's do synthetic division. I'll let you do the work in the calculator, and I'm going to use synthetic division. So I got me a 1, a 3, a 9, a negative 6, a negative 5. Bring down my 1. 1 times 3, 3. 3 plus 3 is 6. 6 times 3, 18. 9 plus 18, 27. 27 times 3, 51. 51 negative 6, 45. 45 times 3 is going to be a big number. What is that? 15, 12, 135. Negative 5, 135 will give me 130. So this should be my answer. When I plug in a 3 here, and a 3 here, and a 3 here, and a 3 here, you should get 130. If I'm wrong, I might have made a mistake, but I don't think I am. So check me. Plug in a 3, plug in a 3, plug in a 3, plug in a 3, and see if you get 130. If you get something different, send me an email or a message. You might get some extra points. Alrighty. So that's synthetic division using the remainder theorem. Just the last problem for this section. It says use the graph to determine a solution of the equation. Use synthetic division to verify that this number is a solution. Then solve the polynomial equation. Okay, so it says which solution of the equation can be determined from the graph. So looking at the graph, remember my zeros, my solutions, my roots are my x-intercepts. So looking at the graph, one of my solutions is 2. Okay, and you have another way to get extra credit. I did the first part. I showed you the graph. If you show me or send me your work using synthetic division to verify that this number is a solution, and you solve the polynomial, you get extra credit towards your test in this unit. On this one, towards your assignment in this unit. Alright, well, thank you so much. Y'all have a great